Hi, my name is David Ho, and I work for the Hydrologic Engineering Center in Davis, California. This video series is part of the basic HEC-HMS class discussing surface runoff. We will be going over the Snyder's Hydrograph method, which is one of the synthetic methods available in HMS. The Snyder's Hydrograph looked at using the hydrograph peak, watershed lag, and the time base to develop the unit hydrograph. This method was developed for studies of watersheds in the Appalachian Highlands with areas ranging from 10 square miles to 10,000 square miles. Snyder's requires two parameters, the watershed lag and the peak discharge. The watershed lag is defined the same as the SCS unit hydrograph method, which is from the center of mass of rainfall to the hydrograph peak value. Snyder's method provides an equation to estimate watershed lag by multiplying CT, which is the timing coefficient, by the length of the longest flow path and the length of the centroidal flow path. CT is a variable coefficient that is best estimated through calibration. The peak discharge is calculated by multiplying 640 by CP, which is the peaking coefficient, by the watershed area and the basin lag. CP has values that range from 0.4 to 0.8 and generally represent retention or storage capacity of the watershed. There are tables that provide typical ranges for the timing coefficient and the peaking coefficient, but the best way is to calibrate for these parameters. The Snyder's method is unique compared to the SCS and the Clark in that it generates several points to define the hydrograph. There isn't a dimensionless unit hydrograph or a time area curve to smooth out the rising limb or falling limb. It's somewhat of a connect the dot exercise to define your shape and making sure that your area under the hydrograph is equal to 1 unit. The graph shown here shows that there is not a lot of definition to the rising limb or falling limb of your unit hydrograph. In HMS, the Snyder's method only computes the 0, initial base value and the peak value delayed by a lag. The method actually calls the Clark unit hydrograph and iterates through its parameters, time of concentration, and the storage coefficient to create a unit hydrograph that matches the Snyder's hydrograph peak value and peak timing. So you're essentially using the Clark unit hydrograph method when selecting Snyder's, but you will still get the peak value and peak timing based on the Snyder's method. If you want to better understand how Clark unit hydrograph works, we have a video under the basic HMS class that discusses the Clark method. To implement the Snyder's unit hydrograph method, you will need to select a subbasin from your basin model. Head down to your component editor and select the Snyder's unit hydrograph in your transform method. Navigate over to your transform tab to enter your parameters. The first is to select the method. In HMS, there's currently 3 methods available. The standard method requires the user to estimate parameters using the standard techniques for estimating lag and the peaking coefficient. The peak discharge of your hydrograph is computed using the peaking coefficient, your watershed lag, and your watershed area. There are 2 other methods available, the Fort Worth and Tulsa, which are methods developed by those districts to account for urbanization. We won't go into any detail, but these approaches may be effective at estimating hydrographs in ungauged watersheds if they are similar to the watersheds used to develop the approach. Thank you for listening to the Surface Runoff video series. Visit our website to learn more about how to use HMS and follow future updates.